ABC, a measure of ABC is a straight angle. It's a line. It makes up 180, so that's what we're talking about right here. Okay. Now, I'm talking about ABC, so out of these two statements I have left, which one should I use next? The one talking about ABC. So the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle ABC. Good. So I'm still talking about ABC. 1 and 2 equal ABC, which is true. Okay, so let's go back down and let's figure out why I know that. Okay, do I know that because of supplementary angles? No, I know that because of angle addition. Piece plus piece is the whole thing, and that's what I'm working with here. Piece plus piece is the whole thing. So that is angle addition postulate. Remember angle addition from chapter 1. All of these theorems and postulates and things, they keep coming back, so you have to learn them. Okay, good. Alright, so I did that. Now, I only have one statement left, so of course it has to be measure of angle 1 plus measure of angle 2 is equal to 180 degrees. Now, let's look and see why they did that, and they already told me that this was substitution, so let's look what they did. We had this statement ABC equals 180. I know 1 plus 2 equals ABC. So I can swap out ABC instead, and I can put the 180 in its place. 1 plus 2 equals 180 instead of 1 plus 2 equals ABC. So I substituted 180 and ABC there. Well, so if 1 plus 2 is equal to 180, we know that means they're supplementary. Oops. Because that is the definition of supplementary angles. Okay, so you should go back through and reread this proof and make sure it makes sense. Now, as you can tell, 1 and 2 form a linear pair, so they must be supplementary. You can look at this picture and see that in 5 seconds. The actual problem, what you're trying to work towards, is you're trying to figure out why, and you're pretending like you're explaining this to somebody who has no idea what they're talking about. So if you just looked at it and said, oh yeah, that makes sense, okay, that's not good enough. That's not what we're trying to do. We're trying to show every step and explain why it's true, not just that it is true. So that's the point of the proof here. Okay, moving on. Alright, vocabulary grid for right angle theorem says all right angles are congruent. And of course that makes sense to us because they're all equal to 90 degrees, so they're all going to be congruent, which is what we're going to prove right here. So I have my given and proof statement. Given that angle 1 and angle 2 are right angles, I need to prove that they're congruent to one another. Okay, so you know the drill. Start with given. Angle 1 and angle 2 are right angles. That goes in spot 1. In the last spot, angle 1 is congruent to angle 2. So we got those two. The very first reason is always going to be given. So just filling these things out right here, I already have almost half of the problem done, and I haven't even done anything. Okay, so this one, instead of giving us choices to choose from, it gives us the plan. So we're going to read the plan and try to follow along with it. So it says, use the definition of a right angle to write the measure of each angle, then use the transitive property and the definition of congruent angles. Okay, so it tells me right away to use the definition of a right angle. So what's the definition of a right angle? Well, a right angle is something that measures 90 degrees. So I'm going to write that. That means the measure of angle 1 is 90 degrees. And the measure of angle 2 is 90 degrees because that's what it means to be a right angle. Okay? Then it says, use the transitive property. Well, you have to remember what transitive is. That's when you have 3 items, 1, 2, 3, and you can use one of them like a bridge. So in this case, our 90 degrees is our bridge. So this is like if A is equal to B and B is equal to C, then I'm allowed to say A is equal to C without using the 90 degree bridge anymore. So that's exactly what I'm going to say. The measure of angle 1 is equal to the measure of angle 2. I can drop the 90 degrees out of the way. They told me what to use. They told me to use the transitive property of equality. Okay, now this last one is one that you've already seen today. The measure of angle 1 equals the measure of angle 2. That means angle 1 is congruent to angle 2. Well, anytime you switch from equals to congruence, the reason is by definition of congruency. You can say congruent angles or segments if that's what you're working with, but you can just say definition of congruency if you want to. Okay, so stop and rewatch that one if you didn't understand what we were talking about. Okay. Alright, so the congruent supplements theorem is one, this is what we're going to prove right here, and this is one that comes back a couple times later in the year, but it's one that people forget. And all that it says is if two angles are supplementary to the same angle, then those angles have to be congruent to one another. And I'm going to take a second to explain why that must be true. So I'm going to draw this picture. Okay, so let's pretend that these two angles are supplementary. What does it mean to be supplementary? It means that together they equal 180. So I'm going to say this one's 80 and this one's 100 just to make this even. Okay, so these two are supplementary. Now, also, these two are supplementary. So if this one is already equaling 100, what's the only choice for this one to be? It has to be 80. Which means if these two angles are both supplements to the same angle, then they have no choice but to always be congruent to one another. And that's what we're going to prove in this one right here. Okay, so this one is fill in the blank. So they've already filled out some of this for us. We just have to do the rest. So given 1 and 2 are supplementary, and 2 and 3 are supplementary, and I need to prove that 1 has to be congruent to 3. So let's fill in the stuff we don't even have to think about. Angle 1 and, oh, I need to write smaller. Angle 2 are supplementary, as well as angle 2 and angle 3 are supplementary. That is the given, always. And then the very last statement is going to be our proof statement. Angle 1 is congruent to angle 3. Okay, so even though these blanks are filled in for us, we are still going to follow along and read them, okay? So, the measure of angle 1 plus the measure of angle 2 equals 180, and the measure of angle 2 plus the measure of angle 3 equals 180. This is the definition of supplementary angles. If angles are supplementary, that means they add up to 180. Look, again, the third time we've seen if a vocabulary word is here, the definition is the next reason. So that's a good pattern to watch out for. Okay, so the third step says that we're going to need to do some substitution. So when you know you have to substitute, what you need to look for is something that they're both equal to. And in this case, they're both equal to 180. So 180 is like my bridge. That's what I'm going to use to say, okay, if they're both equal to 180, then I can set them equal to one another, and that will be good. Good. So I eliminated the 180 and I went straight from 1 plus 2 equals 2 plus 3. I basically substituted 2 plus 3 in for 180. I swapped it in there. Okay, step 4, measure of angle 2 equals measure of angle 2. This is something that we saw in 2.5. If we see the same thing equal to itself, that's one piece. So that is reflexive. 1 is R, 2 is S, 3 is T. Reflexive. And it's an equal sign, so it's reflexive property of equality. This step seems silly, and it still does to me 5 years later, but we just are saying that this is the same angle 2 in both sides. I don't have two different angles that I'm talking about. So I'm letting people know this is the same thing. Now this step is the hard step of the proof. How did I get from 1 plus 2 equals 2 plus 3, and then I got 1 equals 3? Well, what you can tell is that I just canceled out the 2's on each side. But canceling isn't a property. That's not what I really did. How come I get to cancel them? Well, what I really did is I subtracted measure of angle 2 from each side, and when I subtracted it, it ended up canceling out. So this is the subtraction property of equality. Okay, and then this last step, we've seen it over and over. If you're going from equal to congruence, that's the definition of congruent angles. Okay, This last one is the definition, it's the congruent complements theorem, which works exactly like the congruent supplements theorem, only it's 90 degrees, not 180 degrees. So I want you to finish this theorem. They gave you the plan, and you've seen it done with supplements, so you can finish this proof, and this will be part of your notes. I'm going to check and make sure that you did this tomorrow when you come to class. Okay? Super, super, super important lesson. So if you're like, what is this proof you're talking about? Stop and rewatch the video so that when you come to class tomorrow, you have a clue what I'm talking about.